Guys, Mrs. C here. This video is going to cover section 2.8 where we graph linear inequalities. However, there's an opener here and I won't take the time to explain it on the video, but I am going to key it out. So go ahead and pause your video and see if you could do these transformations. This is what we talked about on the last lesson, and then you can check your work. All right, so for part A, this -2 is in the K position, so the graph should have shifted down 2 units is all. Over here, the 1/2 is in the A position, in which case all of your y coordinates are going to be chopped in half. So this -4 has been translated to that -2. And this 2 has been translated to that 1. And this 3, the lines are really faint and hard to see, but this has gone to 1.5. So if you just can do that without making the XY chart, then feel free to do that. But here's what the XY chart would look like. Right? This is where we take our the parent function coordinates and we just multiply the y coordinates by 1/2 and get our new y coordinates. And then we put the new y coordinate back with the x coordinate and we plot that new point. And you just have to keep track of, what point is getting moved to where. All right, I did not show the chart on this one, but that's a -1 in the A position. So all of your y values are going to be multiplied by a -1. So this -4 gets reflected over the x to +4. Right, that +2 in the y gets reflected over x to -2, and that -3 gets reflected over x to -3. All right, and then part D is the one that you should do in 2 parts because this has everything on it. It's got the stretch and the 2 shifts. So do the stretch first. Take care of the doubling your function. So multiply all your y values by 2, and that's my dotted line right here. Okay, so now the dotted line should look like it's twice as, it's been stretched double what the original parent function was. Okay, and I'm going back up to, I don't think I said it, but this pink graph should look like it's been compressed. Your overall finished product should look half the height as the original one. Right? This one right here, when we doubled our y values, we stretched it. All right, and then we do our translations. So this is a -3 in the x and a -1 in the y. So this coordinate went -3, -1, -3, -1 to here. This one went 3 left, down 1. And this one went 3 left and down 1. Okay, so it should be shifted and look twice as tall. Okay, so the next part is a gentle introduction to inequalities. So this is multiple choice. Which ordered pair is a solution of this inequality right here? And so ordered pairs are x, y. All we're going to do is plug in the x, y values and check until we get a solution. Okay, so I'm going to plug 0 in for the x and a -3 in for the y. All right, and it's like we're asking a question. Is the left-hand side going to be less than or equal to 6? Okay, so 6 is not less than 6, but this is a less than or equal to sign. So I'm thinking this is the correct answer. Just to check the other ones, I won't do it on camera, but I'll do it off camera and show, and you guys might want to do the same thing just for some practice. All right, so this one is the true one. So remember, you just have to be less than or equal to. It doesn't have to fulfill both qualities in order for this to be a solution. So this one is the yes, this one is no, this one is no, this one is no. All right, so on the back side of the notes, we are going to do some graphing, and we are going to follow these general set of directions. So for step one, we first graph the boundary line, which is just the regular old line that you would graph if you were just graphing a regular linear equation. What we are going to change a little bit about it is that if you have just a less than or greater than symbol, we make a dashed line for our line. All right, and if you have the equal to on it, we make a solid line. Okay, and then these are the graphs that have shading on one side or the other. So the way that you figure out where to shade is by testing a point. So we're going to test a point not on our boundary line to determine whether it is a solution of the inequality. If it is a solution, we're going to shade the half plane that contains that point. If it's not a solution, then you shade the other half plane. Okay, so example 2, we're going to graph and shade x is less than or equal to 5 on a coordinate plane. So that means we go on the x-axis to 5, and we draw a line. We're going to keep in mind that because it's got the equal to on it, we're going to make a solid line versus a dotted line. Okay, I mean, this one's pretty simple to shade because we're going to shade any x value that's going to be less than or equal to 5. So I feel like we don't really need to pick a test point because you can really easily see all the x values that are less than or equal to 5 are on this side of the line, right? To the left of the line. So we're going to shade the left. This is called a half plane. And all that means is that any coordinate you pick over here is going to satisfy the inequality. All right, example 3, we're going to graph this inequality. So the first step is to get the border line onto our paper. So for that, we're going to just think about the inequality as an equation. So we don't get caught up in that sign or doing any flipping if we're dividing by a negative. I think this one is easiest. It's in standard form, so I'm going to go ahead and graph it in standard form. So I'm just going to get my zeros set in my x and y position so I don't goof up what goes where. So this says I'm going to plug 0 in for the x, and y is going to equal -3 if I solve this little bit right there. And this means I'm going to plug 0 in for the y and then solve 3x equals 12. So that's going to be 4. All right, so 0, -3. 4, 0, plot the two lines. All right, and now we're going to consider, should this be a dashed line or solid? And since there's no equal sign under there, I'm going to make a dashed line. All right, and then step 2 is to test a value. So pick a point on either side of the line. Usually 0, 0 is just the easiest point to pick. So we will just go ahead and test 0, 0. All that means is we're going to plug 0 and 0 up into our inequality. And it's like we're just asking the question, oops, 4 times 0. When I plug 0 into the left-hand side, is that going to be greater than 12? So is 0 greater than 12? And the answer is false, right? 0 is not greater than 12. So we picked our test point here. It wasn't a solution, which means none of these are solutions. That means all the solutions exist on the other side. And we don't really need to test them unless you want to. We can just shade the other side of the line. All right, here is a word problem. So it reads, you have 2 part-time summer jobs, one that pays $9 an hour and another that pays $12 an hour. You would like to earn at least $240 a week. Write an inequality describing the possible amounts of time you can schedule at both jobs. And then we are going to try to graph this. I'm not sure why there's a line through there. That was a mistake. All right, so we have these two scenarios. We have the hours worked at $9 an hour and hours worked at $12 an hour. So we'll just go ahead and let x equal hours worked at $9 per hour, and y will be hours worked at $12 per hour. Okay, so when you think about working a job for $9 an hour, if you work for 1 hour a week, you're going to earn $9. 2 hours a week, you're going to earn $18, or 2 times 9. 3 is going to be 3 times 9, etc. So the total amount of money that this job is going to earn is going to be $9 times however many hours you work at that job. And likewise for this one, the amount of money you're going to earn from this job is going to be $12 times all the hours that you work at that job. So what we'll do is add the two dollar amounts together, right? 9x represents all the money that you're going to earn at the $9 per hour job, plus 12y. And we want that to equal at least, right? You want your earnings to be at least $240 each week. So now we just have to replace this at least with the correct inequality symbol. So basically what that means is that 240 is the smallest amount of money that you want to earn, because you want to earn at least that, and which means you want to earn that or more. So that means when you think about alligator mouth eating the bigger side, we want this to be the smallest dollar amount, and this is all the money that you want to earn. We want this side to be bigger. So alligator mouth eats the bigger side, right? And if we want to earn at least, we could also earn $240. So I'm going to put an equal to symbol there. All right. So this one is set up for in standard form. And let's see, I think I'm going to graph it in standard form, although it looks like one of my intercepts is not going to be an exact number, but I'm just going to say let's go decimal with it. And I do feel like decimal with word problems is acceptable. Decimal with little teeny ones that you're trying to just put on your paper is not acceptable. Okay, so let's see. If I plug 0 in for the x, right, I am going to solve this for y. So 240 divided by 12. Well, that's actually not too bad, right? I think that's just 20. Okay. If I plug 0 in for the y, I'm going to cover that up. Then what I have left is 9x equal 240. But 240 divided by 9, that doesn't go evenly. 240 divided by 9, I'm just going to take the decimal, 26.7. Well, it looks like 26 2/3 of an hour. Okay. So over here on my graph, let's see. I think can't count by ones. 2s, this goes up to 10, so that'd be 20 and 20. It's still not big enough. Look, I'm going to count by 5s. 5, 10, 15, 20. Let's see. 25, 30. And the other side is going to go, let's see, 5, 10, 15, 20, 25, 30. All right, so I have 0, 20, so that goes up to here. And I have 26.7, so here-ish. All right, and this one looks like it's going to be a solid line. I know, I got weird shadows on my paper. My hand will be in the way for a second. Go ahead and plot your line. All right, and now I'm going to test a value. So test 0, 0. So if I plug 0 in for the x and 0 in for the y, I'm like asking that question, is that going to be greater than 240? Definitely not. Okay. So that means I am going to shade on the upper half of this line. All right, so that means any xy coordinate that you pick out here is going to be the number of hours that you have to work at these two jobs to earn at least $240, right? So I just randomly picked 35 hours at the let's see, at the $9 per hour job combined with, wow, that's a lot of hours combined with 10 hours at the more expensive job. I mean, I guess if you look at this point right here, this one is on the y-axis. This pretty much says that you have to work $20, 20 hours at the $12 per hour job and 0 at the other job in order to earn at least $240 per week. All right, and last example, we have an inequality absolute value. All right, so don't panic. All right, to just get the graph on the paper, just think that that is an equal sign. So that's like a -1 in the front, x plus 2 minus 1. All right, so this is our h and k values. Opposite in the h direction, same in the k direction. So -2, -1, we start here. And then our normal graphing pattern is 1, 1, 1 times by a -1. So it's going to be -1, -1. That just flips it down. Over 1, down 1. Over 1, down 1. Okay, so now to get it on the paper, we have to consider solid line or dashed line. So we go back up to that symbol, and since it's got the equal to on it, we'll go ahead and make a solid line. And now we're just going to pick a value to test. All right, let's test 0, 0. Okay, so I'm going to plug z. I'm going back up to the original. So 0 is 0 less than or equal to question mark negative 0 plus 2 minus 1. So the negative is unaffected by the absolute value since it's outside of the absolute value. So absolute value of 2 is 2. Negative comes down to the next step. Am I off the screen? I'm just about off the screen, aren't I? All right. So is 0 less than or equal to -3, right? So when you think on a number line, here's 0, here's -3. No, right? 0 is greater than -3. So that means that 0 is not a solution. All right, so that means all the other solutions happen inside the V. And if they didn't happen, and if 0 was a solution, it means you would shade everything outside the V.